Okay, let's dive into this. Welcome to this explainer. Today, we're exploring an absolute marvel of modern engineering. We're talking about a structure that holds the undisputed Guinness World Record for the longest bridge on Earth. We're looking at the Danyang-Kunshan Grand Bridge in China. And look, this isn't just your standard highway overpass, right? It's a staggering, absolute beast of a mega project that completely rewrote the rules of transportation in one of the globe's most vital economic hubs. We're going to explore exactly how they pulled this off, the wild geographical hurdles they faced, and honestly, the mind-blowing numbers behind it all. To really grasp the mind-boggling scale of what we're talking about, just think about this for a second. The Danyang Grand Bridge stretches an astonishing 164.8 kilometers. That's about 102.4 miles. So imagine hopping in your car in New York City and driving all the way down to Philadelphia. That entire road trip city to city? That's the length of this one continuous bridge. If you were to drive across it, it would literally take you longer than traveling between many major metropolitan areas around the globe. It's just a completely unbroken structure that totally shatters what we expect a bridge to be. Section 1. The Challenge: Conquering the Yangtze Delta. So, the crucial point is, why on earth would anyone need to build something this massive in the first place? Well, back at the dawn of the 21st century, China was experiencing this unprecedented economic boom, and it created a totally massive transportation bottleneck. They desperately needed faster, more reliable connections between major urban centers, but, geography was literally standing in the way. The Yangtze River Delta is this massive region packed with endless rice fields, mazes of canals, deep wetlands, large lakes, and super dense cities. Trying to build a traditional ground-level railway through that, it's a logistical nightmare. Sinking wetlands and rice fields means soft, squishy soil. You absolutely cannot run high-speed bullet trains over shifting mud. Plus, trying to carve a path through heavily populated areas and crucial farmland would have been incredibly disruptive. So, the solution the engineers landed on was radical. Just elevate the entire railway on a giant viaduct. Basically, instead of fighting the unstable ground and tearing up cities and farms, they said, hey, let's just go right over the top of it. By lifting the tracks high into the air, they completely bypassed all that soft soil, the waterways, and the urban congestion. It was a real game changer because trains could travel significantly faster, be way safer, and cause barely any disruption to the people and ecosystems down on the ground. Section 2, Engineering the Impossible: Building the Viaduct. Let's move on and see how this builds, because the sheer audacity of this construction phase is where things get really wild. Building a bridge this long over such a notoriously soft, shifting foundation is no joke. They officially kicked things off in 2006 and wrapped it completely up by 2010. 4 years! How is that even possible? Well, they deployed an absolute army, over 10,000 workers operating simultaneously across the region. The secret sauce was using prefabricated modular concrete sections. Engineers would cast these massive chunks of the bridge off-site, truck them over, and basically drop them perfectly into place like giant Lego bricks. By pouring staggering quantities of concrete and erecting thousands of columns at warp speed, they opened this massive high-speed artery to the public on June 30, 2011. Now, moving that fast didn't mean they cut any corners on safety. Actually, this specific region gets hit by some pretty catastrophic threats, but the engineers completely disaster-proofed it. This thing is built to take direct hits from powerful typhoons and extreme seasonal flooding. Even crazier, it's designed to survive a massive magnitude 8 earthquake. Oh, and since it crosses navigable waterways, the structural supports are literally reinforced to withstand being rammed by huge commercial ships at high speeds. It is, without a doubt, one of the toughest, most resilient structures humanity has ever put together. Section 3. The Crown Jewel, the Yangsheng Lake Crossing. Out of that entire 164.8 kilometers, there is one particular stretch that is just the absolute standout. It's the most complex and beautiful part of the whole mega project. Right in the middle of the route, the viaduct has to cross the wide open waters of Yangsheng Lake. Now, you might be wondering, why not just go around? Well, at these speeds and scales, you need straight lines. So they built a continuous 9-kilometer, that's 5.5 miles stretch, directly over open water. You can't exactly drive a dump truck onto a lake, right? This took highly specialized aquatic gear, floating platforms, and incredibly strict environmental planning, so they didn't wreck the lake's delicate ecosystem while they worked. Now, what's really interesting about this is what it took to hold that section up. For just those 9 kilometers, they had to drive 2,000 individual support pillars deep beneath the surface of the water, anchoring them firmly into the lake bed. 2000. It's an absolute engineering marvel on its own, and today it stands as easily one of the most stunning, highly photographed parts of the entire bridge. Section 4. Transforming modern travel.
So, taking a step back from all the nuts and bolts of construction, what does all this actually do for the people of Jeonju province? Well, it didn't just break a world record, it totally revolutionized economic connectivity. Imagine taking a grueling, multi-hour, obstacle-filled commute and slashing it down to mere minutes. Historically, traveling between these major hubs was slow and exhausting. But today, bullet trains are literally flying across this perfectly level viaduct. We are talking about cruising safely at speeds well over 300 kilometers per hour. By flattening out the world and flying above all the hurdles, travel times plummeted, connecting millions and totally turbocharging the economy.
Let's do a quick rapid-fire rundown of the stats that define this mega project because they are staggering. Length, 164.8 kilometers. The price tag to make it happen? A cool $8.5 billion US dollars. It took a coordinated workforce of over 10,000 people, and from the first shovel in the ground to the final track laid, it took just 4 years. It is honestly no surprise at all that this is still the reigning Guinness World Record holder. And this brilliantly illustrates that the Danyang Grand Bridge is way more than just concrete and tracks. It's a literal monument to modern ambition and innovation. It proves exactly what is possible when advanced technology, determination, and truly massive-scale planning converge. Over a decade since it opened, it remains a breathtaking, defining achievement of modern human capability. So, having explored the undisputed king of bridges, a structure that turned endless wetlands and congested cities into a seamless high-speed corridor, it leaves us with a fascinating question. As our tech gets even better, and our world becomes even more connected, what massive geographical obstacles will human ingenuity conquer next? Are we going to build longer, faster, or cross even wilder terrain? It's a thrilling thought. Thank you so much for joining me for this explainer. I hope you found it as incredibly fascinating as I did.